So now it's time to calculate the probability of an event. Probability of an event. So the probability of an event A, because that's what the event we have taken here. Event A. Event A is nothing but an odd number. Odd number. So the probability of an event A measures how often A will occur. That's what. How often A will occur. The probability of event A is nothing but how often A will occur. We write this as P of A. P of A. Probability of event A. That's how we read. Probability of event A. So suppose that an experiment is performed n times. The relative frequency for an event capital A is then the relative frequency. That's how we calculate the relative frequencies. Now, number of times capital A, that event A occurs, divided by n. So that is equals to frequency divided by n. So if we let n get infinitely large, then we use a limit in spite of that. So probability of A will become limit n tends to infinite and f divided by n. Because as n is going on to the infinite, then a limit n tends to infinite and f divided by n. That's how we represent. And so based on the n value, we replace that n value, because n tends to infinite. It goes on. That's why we call it as a limits. It goes on. It's a limitless. It will go on. So limit n tends to infinite, f divided by n. If n gets infinitely large, if n doesn't get infinitely large, we will use this one. If n is infinitely get large, then we use this one. Okay. So now some of the properties of the probability of an event. So P of A must be between 0 and 1. That's the probability of event A must be between 0 and 1. If event A can occur, if event A can never occur, then P of A is equals to 0. If event A can never occur, then probability of A is equals to the 0. This is called certain probability. If event A always occurs when the probability is performed, P of A is equals to 1. If any event which always occurs, the probability of the respective event is 1. If an event A can never occur, then the probability of that respective event is 0. So the sum of the probabilities for all simple events in S equals 1. Very, very important point. The sum of the probabilities of all simple events are simple event. Again, distinguish the difference between a simple event and an event or compound event. So the sum of the probabilities for all simple events in sample space S equals 1. Okay. Obviously, the probability of an event capital A is found by adding the probabilities of all the simple events contained in A.